Be Scientific Series 7. Do we have a navigation system in space? The answer is no, as far as I know so far. Okay, let's look at the history of navigation technology very quickly. Okay, you know the ancient people look at the night sky, North Star. The star was a guiding. The problem is you have to wait until night to see it. And also if you go cross the equator, you cannot see North Star anymore. That depends on the season, but these are the problem. So around the equators, North Star is not reliable. Well, South Star is not that clear where to locate. So ancient people use a star. It's a very primitive way to do it, right? Now, you know the Chinese invention, the compass, right? The compass, how it look like. Here you go. This is magnetized spoon. They discover this spoon, you put it on the plate. Its point always the same direction. From here they got idea, this is a nose. Okay? And this compass, the discovery of compass was very significant, because now you can tell which one is north and which one is south, right? And even daytime you can tell the direction. So navigation started using compass. But when you can tell which one is south, the latitude is from equator. It's 15 degrees, 30 degree, 45, 60 degree, 90 degree. This is the latitude. This is north, this is south. And you can divide the earth like a watermelon, right? You cut the watermelon, and the prime here it is England, and you can divide into every 15 degree, and that's 1 hour. Okay, so once you know where the south is, they could determine the latitude, because Earth is tilted. So this is a seasonal adjustment alpha. Okay, you have to know which season you are, so which way, how much it's tilted. And you look at the compass, and when the sun goes south, means the sun is above you. You measure this angle, right? And this angle same as this angle. So from this angle you deduct seasonal adjustment, and that's the latitude. Okay, so the sailor could determine latitude using compass, because they know exactly when the sun goes up south. Then they can measure this angle, right? Just put up the stick and look at the shadow and connect, measure this angle. Okay, longitude was a problem. How do we do longitude? Okay, longitude was measured by clock. Say you left England and you keep track of the time. When the sun goes up on the south above you, the time difference, if it's 3 hours, then you are 30 degrees off from England. So that's the way the longitude was made. So this is a longitude. Divide Earth into this fashion, and you determine where you are, and the latitude determine where you are here. Okay, so you can tell your location. And in order to do that, you needed a clock. So the Chinese invented the first mechanical clock, and the mechanical clock is necessary to put it on board on moving ship, right? The water clock and all others, ancient clock, is not suitable for the ship. So China was way ahead in the navigation system, and Admiral Zheng He I think he beat Columbus. He went to the Africa way before Columbus, and brought back the giraffe for the emperor. Okay, they had a navigation system. Only question is, did he go farther from Africa, China to Africa, and go around to the America? And I saw the documentary. It's very interesting. They are still arguing, see if he came to U.S. before Columbus. Okay, and there was a rumor that at the Mississippi River there was a Chinese monument stone with Chinese characters, but they exploded and eliminated it. The early immigrant from Europe. Okay, they don't want to see that kind of things. So that's a rumor. Now there's no evidence, so it's just a rumor. But they are still arguing about who came to US first. The China had all this navigation technology, latitude and longitude, mechanical clock, before Industrial Revolution in British. The England had a Industrial Revolution that changed everything. They made the metal ship with a steam power engine and built up the world navies, invincible navies, and they start going out to make a colony all over. So that was a change in the history. But before that, navigation system was this way. Now, when you have latitude, longitude, this kind of method you cannot use in the airplane. The new technology for the airplane is called VOR, and there are several others ways to do it, but basically what the VOR is, in every airport has a VOR, and it's emitting signal, and each direction, each slightly different angle, emitting slightly different signal. And when airplane come, it's receive those signal and determine the angle from airport. Okay, so airplane can keep flying to the airport. Every airport has VOR and sending out the signal. The airplane detect this VOR so they can fly to that airport. Okay, now this shows only angle. You're flying to the right angle or not. This is more advanced system than latitude and longitude method, right? Now the signal coming, so it's for sure you are going there. And also there is a new device like measuring the distance from the airport. Okay, and the distance, you can tell distance getting less and less means you are getting close. And check with the speed. The speed in the air, we have a pitot tube, right? And the pitot tube use the air pressure to measure the speed. So those are the modern technologies for navigation, right? So, okay, so once you jump out the atmosphere, what can you do? Okay, we have another navigation, very modern technology. Traveling space, well, we are back to looking at star again. And since we are in 3D, one North Star cannot tell. If you are on the surface of Earth, you can tell which way is north. One star is enough. But if you are in a 3D space, you need at least 2 stars to look at. And this is a very primitive method. Okay, you keep this angle when you leave the Earth, and the moon is moving, right? So you guess it's going to be here when you go there. So in order to go straight, you look at the star and look at the star. Keep the angle same. Okay, Each angle define one plane. So two planes define this line, straight line. The problem is this method is so primitive that there is a Earth's gravity in the beginning, so it's not keep going at the same speed. Okay, there's no way you keep going at the same speed. The speed decrease, and over some certain point, the moon's gravity gets stronger, since the speed start increasing. But moon is moving, and you have to come here. You have to come here at the exact moment. But you don't know whether you arrive here at the exact moment, because by looking at the star, you know you are on track, but you don't know how close to the moon. Can you use a radar? Well, radar, in order to put out that strong microwave, you need a big power source, and there's no way this lunar module has that kind of power source, so you cannot use a radar. Okay, so, and another problem here is this one. Once if you drift off and they say, oh, we are off, correct it, you cannot go back. You just keep going on the parallel line. So what's happened? You completely miss it. So this is so unreliable navigation system, and I don't know what kind of navigation method used in the last European Space Union. They sent a probe to Mars and got lost 2 years. Okay, and suddenly they got a signal 10 seconds before crashing to the Mars. They got a signal, so they got at least 10-second Mars image. Suddenly you see the Mars ground coming close at you and crash that 10 seconds. And all the money spent and 2 years effort was only 10-second image. Okay, so navigation is not that easy in the space. Honestly, I don't know what kind of method the European Union used. Maybe same as NASA. I look at the Amazons, the Moon Explorer, and they said they have lander has telescope to look at the star. So using this method, and this method is such a primitive, unreliable method. It's like you're floating in the sea in ancient times. Look at the North Star, and they say, yeah, we gotta go this direction. That's a kind of primitive method. Okay, but I read the article. The China said when they send the lunar module, they do 3-time adjustment of speed and position. How do they do that? When they leave the Earth, they adjust the speed and this trajectory, and in the middle they do one more time, and before moon, getting close to moon, they do adjustment one more time. That's a speed and trajectory. And speed is easy if you can tell how far you are from Earth, right? Because you measure position and 1 hour later measure again, and the difference times 1 hour. That's a speed. Okay, so how do they locate the lunar module from Earth? Okay, and I checked. It's just China launched a satellite that emit X-ray navigation signal. The X-ray, and at least four satellite. And X-ray is coming just like a VOR, right? And this module detect direction and triangulate to find out the position from Earth distance. And once you know the distance, the speed is easy. You measure distance twice within a certain time and divide by time. It's going to give you the speed. Okay? So, I think this is, if this is true, only China has this navigation system. Okay? European Unions and nobody has this. And even Amazon's new exciting moon lander, well, they have this telescope to look at the star. Very primitive method. And this is the recipe for failure. You need much more advanced navigation system. Like probably China doing this, X-ray, because they said they adjust speed and trajectory 3 times before going to the moon. The last time, the Israel sent the lunar probe. What Israel did is they stretch the orbit longer and longer. So it took 1 month, and finally the orbit became long enough, then got onto the moon's orbit, right? But it's crashed onto the moon, and that was like 1 or 2 months ago. But this method takes 1 month because you are correcting orbit all the time, and it takes time. The usually trip to moon is like 2 days. And China, when they send the probe, it's 2 days trip to the moon. And Israel took 1 month. This method is safer. You can go without navigation system probably, but it's just too slow to get there. The human on board 1 month, what do they do 1 month? Play card every day. So you can't do that. 2 days trip. Some kind of navigation system is necessary. So far I haven't seen anything. We don't have a navigation system, and very unfortunate. When I saw that, Bezos announced, we have a moon lander, and he explained, and he said, what is this little corner? Oh, this is a telescope to see the star. And I got, are you serious? Are you going to use this primitive method? You're going to get lost in space. Okay? We need like a VOR. This is like a VOR space version. Okay? I think China is back. The navigation system is way ahead. That's why every time they send something to moon, no failure. It's go there and land it. Because they announced so far Chang'e 1, 2, 3, 4, and 5 landed on the other side of the moon. And they have relay satellite going around L2 point. That's another one. So many satellites they sent to the moon, and every one of them is successful. And the Chang'e 5 test module, they did rendezvous around the moon and came back to the Earth. Okay. So that's about the navigation system in space. I hope you enjoyed this video, and if you like, subscribe.